Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.4, Problem 13. This is Section 15.4, Problem number 13. We have the definite integral of 2x to the 5/8 power dx from 1 to 0. So what makes this problem a little different than some of the others is this unusual fractional exponent. So just deal with it as you would with any other number. So when we do the integral, you'll have 2, the number in front, times the previous exponent, in this case 5/8 plus 1. Keep the variable x to the previous exponent, which is 5/8 plus 1. So now it becomes a matter of simplifying this messy fraction. So let me start with this. 2 over 5/8 plus, instead of plus 1, let me write that plus 1 as 8/8. X to the, and then same process with the exponent. 5/8 plus 1 will turn into 5/8 plus 8/8. The 1 really can be written as 8 over 8, but now it's in a form with a common denominator. It's going to be much easier to deal with. So still have my 2 on top. Now 5/8 plus 8/8, the common denominator is 8. And if I combine the numerators, 5 plus 8, I get 13. X to the, this is going to be the same answer. Common denominator is 8. Combine the numerators, positive 5, positive 8, positive 13. So that's better, but I still have that 2 over 13/8. So I have a fraction with a fraction in the denominator. So what I'm going to do is flip that 13 over 8, it becomes 8 over 13 times the numerator. So I'm going to have 8 over 13 times the 2 that was on top, x to the 13/8. And to do a multiplication of a fraction times a whole number like that, let me put a 1 under the whole number. So I'll keep the 8 over 13 in front times, instead of 2, let me write the 2 as 2 over 1. That's still a 2. And then I have x to the 13/8. So now when I multiply my fractions, top times top, 8 times 2 is 16, bottom times bottom, 13 times 1 is 13. So I have 16/13 x to the 13/8. That's the answer for the integral, so I put a long vertical line to the right of that. I put in my limits of integration, 1 for the upper limit and 0 for the lower limit. These are the values I'm going to plug in. So basically I'm at the end of step 1 of a 4-step process. Step 2, put in the upper limit of integration in for my variable. So 16/13 x becomes 16/13 1 to the 13/8 exponent. Well, fortunately, 1 to any exponent is just going to stay 1. Like 1 to the 3rd, 1 to the 4th, 1 to this weird fraction. It's just 1. Times the 16 over 13 in front will be 16 over 13. So that's the result I get when I put in the upper limit of integration. I get 16 over 13. That's my step 2 result. Step 3, put in the lower limit of integration, the 0, for my variable. So I'll have 16 over 13, 0 to the 13/8 power. Well, the 0 is especially easy. 0 to this unusual fractional exponent is just 0, times the 16 over 13 in front is still 0. So for step 3, I get 0. Step 4, subtract the step 2 number minus the step 3 number. So 16 over 13 from step 2 minus 0 from step 3 gives me 16 over 13. And if you want, you could convert that to 1 3/13, either form, whichever one is easier for you.